We talk to AI every single day, whether we are just asking a smart speaker for the weather or we are telling an AI agent to summarize a really complex document. We give it commands, we ask it questions, we're constantly feeding it information. We kind of just assume it gets us, right? But have you ever really stopped to think about it? How does a machine truly understand the nuance, the history, all the unsaid things that are packed into our words? Well, it turns out it's not magic at all. The secret is actually a formal discipline, a whole field of study, in fact, called context engineering. And here's the real kicker. While it feels like the absolute most cutting edge thing happening in tech right now, the truth is this whole field it's much older than you probably think. Okay, so we've got this secret sauce called context engineering. But what actually is it? Let's break it down. So here's the official definition from the research. It's the systematic process of designing, organizing and managing contextual information so that machines can act in ways that align with human intentions. Now, I know that sounds super academic, right? But think of it this way, it's the art and science of taking our messy, chaotic world and preparing it in a way a machine can actually understand. It's way more than just writing a good prompt, it's about architecting understanding itself. To really get this, we've got to rewind the clock a bit. Let's go way back in time and look at the hidden history of this field. Welcome to Context Engineering 1. Long before ChatGPT was even a glimmer in anyone's eye, the groundwork was already being laid. I mean, way back in 1963, Sketchpad gave us the very first graphical interface. Then in 1991, Mark Weiser was already dreaming of ubiquitous computing, this idea that tech would just be woven into the fabric of our lives. By 99, the Context Toolkit made the idea of context aware apps official. And of course, in 2007, the iPhone put all that power right into our pockets. Every single one of these steps was leading up to the massive shift that came with models like GPT-3 in 2020. Now, in this early era, relationship between us and computers was completely different. The machines were powerful, sure, but they weren't very smart. So we, the humans, had to do all the heavy lifting. We were the intention translators. We had to take our complex goals and painstakingly break them down into simple, structured commands the machine could actually follow. And get this, researchers were already thinking about this stuff systematically. All the way back in 2001, Anin Kadai defined context as any information that can be used to characterize the situation of an entity. This just shows that these core ideas of understanding the user, the application, the environment, they've been central to computing for more than 2 decades. Okay, so all that early work, all that historical groundwork was basically setting the stage for a massive shift around 2020 with the arrival of large language models like GPT-3. Everything, and I mean everything, changed. We walked into an entirely new era of AI. This table just lays out the great AI shift perfectly. In era 1, you had primitive computation, which meant human effort was super high. We had to feed it structured data and work with simple rules. But now in era 2, the roles have completely flipped. We have agent centric intelligence. Our effort is way lower because the machine can now interpret our or intent right from our own natural language, and the core mechanisms are now things like prompting, sophisticated memory, and techniques like retrieval augmented generation or RAG, which basically lets an AI pull in outside knowledge on the fly. So here is the really crucial point. The whole game shifted from context over to context cooperative. A context aware system from era 1.0 would just follow a simple rule. If my location is the office, then silence my phone. It just reacts. But a context cooperative system, an era 2, it collaborates with you. You can ask it, hey, based on my previous paragraphs, suggest a title for my research paper. It's not just reacting, it's reacting and reasoning and actually participating in a complex goal with you. So that brings us to today. How do these modern AI agents actually pull this off? How do they manage all this context? Well, it really boils down to a three-stage process. First up is collection. The AI has to gather context from all kinds of places: the words you type, the you show it, even your user history. Second, management. It can't just be a messy pile of data. The system has to organize and structure all that context so it can be used efficiently. And then third is usage. This is the magic moment, right? Selecting the exact right piece of context at the exact right time to do the thing you asked it to do. I absolutely love this analogy from Andre Karpathy. He said, think of the AI model as a CPU and its context window is RAM, fast but limited working memory. This just perfectly captures the core challenge here. The AI has this incredibly powerful brain, the CPU, but its active working memory, that context window, is finite. You can't fit everything in there at once. So, to solve that exact RAM problem, engineers came up with what they call a layered architecture of memory. It's basically a clever system designed to organize information into different layers based on how urgently it's needed and how long it needs to stick around. It's a really smart way of dealing with that limited working memory. And what's so cool about this is how much it actually mirrors our own brains. The AI has two main kinds of memory. There's short term memory, which is like RAM. It holds what's happening right now in the moment inside that context window. It's super fast, but it's limited and temporary. And then there's long term memory. This is like a hard drive. It stores the important stuff, the abstracted knowledge for the long haul, so the AI can pull from it later. It's the difference between remembering the sentence you just heard and remembering who your best friend was in elementary school. So, with this really sophisticated new architecture, this layered memory that kind of mimics our own, AI is no longer just a tool that reacts, it's becoming a partner that actually remembers and reasons. And that partnership is evolving at a breakneck pace, pushing us towards some truly mind bending possibilities for the future. Because this journey from era 1.0 to 2.0, well, it's not the end of the line. We're already on the cusp of what researchers are calling era 3. And this is the era of human level intelligence. Just imagine an AI that's not just an assistant, but a true collaborator, one that can understand nuanced social cues, pick up on your emotional state, and even get your unstated intentions just as well as a human colleague could. The friction of having to translate for the machine just almost completely disappears. And if human level AI isn't wild enough for you, the research actually speculates one step further into era 4.0, superhuman intelligence. At this stage, the relationship we have with AI completely inverts. The AI won't just understand the context that we provide, it will be so intelligent that it can actively construct context for us. An intelligence that could uncover needs and insights that we haven't even figured out how to articulate for ourselves yet. And this all leads to a really profound, almost philosophical conclusion from the researchers. The human mind may not be uploaded, but the human context can, turning context itself into a lasting some form of knowledge, memory, and identity. Which leaves us with one final, pretty massive question to think about. If all of your digital interactions, your history, your preferences, your entire context can be preserved and actually live on, what does that ultimately mean for the future of human identity?